Good morning. Welcome to Zigmology, a byproduct of Sigma Data by Passion Bytes. So, as you see, ask your data a question and get the right answer for the first time. Is it not possible today? Yes, it is possible with hallucinations, with guessing, and with lots of tokens passing across. So, let's first look into what are the available methods today to do this thing in the world of AI. First is, of course, the retrieval augmented generation, where from your data you do the embeddings and then it is broken into chunks of text and those are stored into a vector database. Couple of problems there. One, what happened to the integrity constraints, the primary key, foreign key relationships, the not null, etc., that are there in the source table already. And the moment you are converting it into chunks of text and storing it into a vector database, those relationships are no more available. Finding a similar text becomes very difficult because the structure is not understood to the retrieval mechanism. And hence the model fills the gap itself and guesses wrong. And if you look at the same thing on a RAG-based architecture, or on a knowledge graph-based architecture, someone has to build the graph. You need to use a graph database. You need to manually create all the relationships, the edges, the vertices, everything. And all the relationships have to be modeled. Any new table, any new column comes in, you need to remap the graph, recreate it. Incremental addition to an existing graph, that's difficult. And again, an incomplete graph is a wrong answer waiting to happen. And you need to go through all the kind of turtle files, SparkQLs, etc. So, both approaches are still guesses and it creates hallucination. How can we do something differently? You already have your relationships in your source system. They are not inferred ones, they are created by the domain experts of your organization. All kinds of primary keys and foreign keys, everything related with integrity are there because that's how your transactional systems work. They are never chunked and they are never lost. So, can we build a kind of relationships or ontology from the existing definitions of the source systems? Yes, we can. Similarly, at the same time, let's say you are belonging to a manufacturing industry or logistics or healthcare or financial services. Why can't we gather the acronyms and the business terms used in the industry with the help of AI and LLM, and then we can tie that information to what we have done here so that an ID might be a claim ID in healthcare, a credit card number for a bank. So we are combining the industry specific acronyms along with the relationships, and then combining together we are creating an ontology, and it is not a knowledge graph. Once we have it, and when we are having a natural language question, we tell the system to refer to this particular ontology we have created so that the right tables, the right joins, and the right columns are being used. Why? Because your question is getting resolved into a grounded information. As a result, there is no hallucination and there is no guesswork, and almost 98% accurate queries are getting created. Well, ask a real question. Zigmology resolves it. The country, the conversion, the time period, it matches to the real tables. And moreover, the power comes by writing a question like this, where your standard SQL now contains a natural language question and it resolves the query. And here you can see that we are calling a function called context engine, and this is completely new and a patented technology where we are allowing a query to be executed on a function written in any language. Normally, in a select query, after the from clause, you will be using a relational database entity name. Here, we are using a function name and passing a parameter to the function, which is your natural language query. And I do want to get the result SQL query accurately by referring to the ontology we have created in the previous session. Well, let's see that in action. I'm going to run a query application, a very simple application. And let us run the Query Studio. And then let's take a normal question and execute this against the query or against the database that we have. And we are going to use a system to give us the answer and click on Ask. Let it connect to the ontology that we have created, which captures the accurate information about what is behind the screens, and then it gives you the complete query with all conditions. In my data, there is no currency called EUR, so I'm just replacing it with USD, and then let us execute this and see whether the result is coming or not. So as you can see here, we got all the data as a result. Accurate answer. Furthermore, let me close the connection and log in as another user, and then let me click on connect and let's see what happens. You can see that this new user is not having a permission to query this particular table from SAP HANA. Beautiful. Now we have added security as well, which might have been difficult if you are using a traditional RAG, because how can you apply the security at a row level or a column level on vector data unless you do that explicitly with much complexity. Furthermore, to show you how this particular function is working, you can now see that I'm going to execute exactly the same query by executing a SQL against a function name, and then you can see it cannot access this particular catalog. Again, the permission is kicking in. Beautiful. We implemented the security. We avoided hallucination and guesswork, and we got almost accurate answer, which is what Zigmology provides. Thank you for listening.